Hello, my name's Daryl Korn, and this is my walkthrough of Project 1 for data mining. Let's get into it. So the outline of my presentation goes as follows. I'm going to go over my three hypotheses, and then I'll discuss my pre-processing techniques and why I chose to do them. And then I'll analyze the data to see if they support or disprove my hypotheses. And we'll cap it off with a brief conclusion. And I'm going to move kind of fast because 10 minutes is not a lot of time to get through all the data that I have. So my three hypotheses are as such. My first one is that major holidays see a change in crime rates, whereas minor holidays will see no significant change. Second one is that violent crimes increase on holidays, whereas nonviolent crimes will occur less often on holidays. And then thirdly, we're going to combine the findings of the first two hypotheses and say that major holidays see an increase in violent crime, as well as a decrease in nonviolent crime, and minor holidays will not see a change in crime rates at all. And these hypotheses were based off of the literature review I did for my project. All right, our first pre-processing technique. So since we are looking into crime on holidays, we need to have an accurate date time of each of these incidents. So when we bring in the data from the LAPD, it looks kind of like here on figure 4.1. It's this sort of string of, time data. And then when I bring it into Python in the pandas, which I use to transform all of my data, it looks like it does on figure 4.2. It actually reads each of these time intervals as just a string. You can see the data type here is an object. And so that won't give us what we need. It's not going to aggregate the data correctly, and we can't sort it how we would like. So we have to specify that, that this column is of date time format. And we also have to specify the specific format of like year, day, month, and such. So that's our first pre-processing technique, very important for these hypotheses. The next one is to explode the records. So when you investigate the data set, you'll find that each record can contain up to 4 distinct crime codes. And you can see that here in figure 5.1, I've shown a few incidents that have 4 distinct crimes within it. And so we want to break all of these out into each their individual records so that we are accounting for all of the data in the data set. I think that's called having proper data verification based on the chapters we're going over right now. So we can see that exploding the records doesn't add a ton of data. So before we exploded, we had around 74,800 battery simple assault cases. And after we exploded the records, we increased it by about 1,000. So that's about a 1% change. Not a huge difference, but I think it's important to make sure we get all of the data for this analysis so it's as accurate as possible. All right, next technique is the group by technique. Here, we want to use daily crime rates to measure our hypotheses. So it's important that we group and aggregate this data by day. And it's kind of tying back to that date time conversion earlier. So we essentially need 2 different data sets for these hypotheses. The first hypotheses will require the first data set where we just group by day, and then we can compare holidays to non-holidays, fairly simple. And the second data set, when we investigate more of like specific crimes on these days, we need to group by not only the day, but also the crime code. So we can see like, oh, 5 burglaries on Christmas compared to, 6 on a normal day. Next technique is to remove the outliers. So after we group by the day and we plot that data out, we get something that looks like this in figure 7 here. We can see from the blue lines, the blue are outliers of the data that I've removed because it was a suspiciously large amount of crime incidents on that day. We can see a lot of them are on the first of the years, like 2020, 2021, and such. Also, everything in 2025 just seems like it's not going to be useful for our analyses. Also, throughout 2022, it seems like there are these weird spikes on the first of each month. So the method I went with for removing these outliers is to remove anything that was beyond 2 standard deviations of the mean. All right. Our next pre-processing technique is to merge in some data. So the data naturally doesn't denote which days are holidays. So I just Google searched that myself, made a quick data set, and I merged that in with this so we can track which days are holidays and which are just an average Joe day. Next, we need to categorize the data into a smaller set of groups. And my figure 9.1 here kind of illustrates why. It may be a bit overkill, but if you graph every single crime code that's in the data set, there's 142 of them. It's just way too much data to look at, really. And we just need to be a bit more focused in our analysis. So I aggregated them into 37 unique crime categories, which is what we see here in figure 9.2. Much easier to view our data at this point and get useful analyses. Also, once I categorized that data, I figured it was also good to filter the data a bit further because we can see here in figure 10.1 that a lot of these categories still don't have a whole lot of data, like manslaughter and bribery at the bottom there with 9 counts each. So I decided to filter to the top 16 most prevalent crime categories, which is what we see here in figure 10.2. All right, on to discussing our hypotheses. So first one was that major holidays see a change in crime rates, and we don't see a change in crime rates on minor holidays. To prove my hypotheses, I decided to compare the distributions of crime rates on the days. And so I figured if the median crime rate on, say, a holiday like Valentine's Day was lower than the median on a typical day, then we can state that crime generally decreases on Valentine's Day. So I created this box plot here to measure the different distributions, and it wasn't very useful, really. You can't get a whole lot out of it. Although one thing that did pop up in this is that New Year's Day here, right on the left, or right, sorry, we seem to only have like a single data point for it. I think a lot of them were removed in the outlier removal step. So from here on out, I've decided to remove New Year's Day from my analysis. But that's about the only useful thing this box plot shows. So what are we going to do to prove these hypotheses? To do that, we should think about our data and how it is time series data, and the data is non-normal. It doesn't follow a normal distribution because it's time series, really. So we need to find non-parametric tests to find a significance level to test these distributions. And from my research, I found that the two methods are either bootstrapping or the Wilcoxon rank sums test. And I decided to go with the Wilcoxon sums test because, to be honest, I didn't really understand the bootstrapping a whole lot. I would love to understand it more, but for my analysis here, I was much more confident in the numbers from the Wilcoxon sums test. So that's what I'll be using for the rest of the presentation. The rank sums test, also known as the Mann-Whitney U-test, it tests whether the medians of two independent groups, if they're significantly different. And what's so useful about it is it doesn't assume normality. So we can use it to see if one distribution is typically greater or less than another one, which is perfect for our hypotheses here. So going back to the hypothesis one, and using the rank sums test, we find that about only 2 holidays see a significant change in crime rates. We see that on Christmas, it generally decreases. So we can tell that from this graph here, figure 14.1. On Christmas, the holiday median of crime rates was 542 compared to 621. And to go further, this W statistic is a positive number, meaning that the typical days distribution is just a bit higher or a bit larger than the holiday distribution. So we also find that the 4th of July holiday, we actually see more crime rates on this at a significant level. The median is greater than a typical day, and we have a negative W statistic indicating that the distribution for a typical day is shifted lower than the holiday median. So I believe that this graph or this data generally supports my hypothesis that holidays have um, a significant change in crime rates, or major holidays do, because 4th of July and Christmas are pretty major holidays as compared to minor holidays like Labor Day or Columbus Day. Although I was hoping to see more major holidays from these findings, so I think generally this does support the hypothesis. All right, hypothesis two. I know we're over right now, so I'll try to breeze through these as quick as possible. Hypothesis two, violent crimes increase on holidays, whereas nonviolent crimes decrease. I think the data supports this hypothesis because we have identity theft, regular theft, trespassing, and bunco are all decreasing here based on these medians and W statistics. Whereas weapon laws, which I would say is a violent crime because it's usually involving the firing of firearms, usually with harmful intent, unfortunately, that is increasing actually on holidays. By the way, bunco, I didn't know what that was at first. Bunco is essentially a con game or a scam. That's what that is. So generally, I think these findings support hypothesis two. All right, hypothesis three, which to remind you was that major holidays see an increase in violent crime and a decrease in nonviolent crime, whereas minor holidays, they see no significant change. And we returned a lot of significant holidays for this one, so this is multiple graphs. Figure 16.1 shows all of the holidays that were significant at the 99% confidence level. We have that decreased crime rates are found for multiple holidays, not just major across all of these graphs. But the 4th of July was the only holiday to see a significant spike in violent crime. And plus, that was at the 99% confidence level. Figure 16.2 here, these are all of the holidays that were significant at the 95% confidence level. And then here on the next page, this graph is all the holidays that were significant at the 90% confidence level. And generally, I would say that all this data does not support my hypothesis. To restate it again, violent crime, it only increased on the 4th of July. No other major holiday did it increase, or really any other holiday. Additionally, other major holidays, this does go with my hypothesis, is that some major holidays do see a reduction in nonviolent crime, but really we saw a reduction in nonviolent crime across multitudes of holidays, major and minor, such as Halloween, Mother's Day. Cinco de Mayo oddly sees an increase in identity theft. I can't explain that, but so generally I think this data does not support my hypothesis. Okay, to conclude, hypothesis one, generally supported. Christmas saw a change in crime rate as well as 4th of July. However, they were the only holidays to see a significant change in crime rates, and I would have liked to have seen more. Hypothesis two, I would say that is supported. It was shown that violent crime increases on holidays and nonviolent crime decreases. And then hypothesis three, putting all this together, I would say it's generally unsupported though at this granular of a level. Data, it showed that nonviolent crime, it decreases throughout major and minor holidays, whereas the only violent crimes to really increase were weapon law violations on the 4th of July. Okay. So that concludes my presentation for Project 1. Thank you for listening.